Assalamualaikum and hi. My name is Muhammad Farhan Bin Azizan and my metric number is MH20062. This subject is under BMA 2312, that is Introduction of Automotive. Today, I will present about an emission control system. Firstly, what should we know is the emission. Emission is the production and discharge of something. But in this presentation, the discharge is more focusing for the gas and radiation. The emission was produced by the combustion in the engine. So, before we started, we should know what is the air we breathe. The air that we actually breathe daily is going to compressive gas will mainly three. For the first is the nitrogen, about 78% air that we breathe. And nitrogen is the inert gas. Nitrogen makes protein in your muscle, skin, blood, hair, nail and DNA. You obtain nitrogen from protein containing food in your diet. According to the Royal Society of Chemistry, this food include meal, fish, legumes, nut, egg, meal and other dairy products. Secondly is the oxygen. The oxygen is the highly reactive gas that we need. It contains 21% that the body needs. Every tissue and every cell in the body needs a constant supply of oxygen to work properly. Oxygen get into our cell and tissue via the lung. And then about 1% is going to miscellaneous element are floating around the carbon dioxide, argon and etc. So, for the emission made by vehicle has harmful and non-harmful gas. For the non-harmful gas is consists from water, H2O, nitrogen, N2 and oxygen, O2. For the harmful gas for human that produced by vehicle is carbon monoxide. Carbon monoxide is produced during incomplete combustion. Anything that lead to incomplete combustion increase carbon dioxide production. Other cause of the high carbon dioxide production include a cool engine, misfiring, incorrect engine timing, defective and worn part, exhaust system leak, and defective catalytic converter. For the next is the hydrocarbon. Hydrocarbon combustion refer to the chemical reaction where a hydrocarbon react with oxygen to create carbon dioxide, water and heat. Hydrocarbon are molecules consisting of both hydrocarbon, hydrogen and carbon. They are most famous for being the primary constituent of fossil fuel, namely natural gas, petroleum and coal. For this reason, fossil fuel resources are often referred to as hydrocarbon resource. Energy is obtained from fossil fuel through combustion burning of the fuel. Although impurities exist in the fossil fuel, hydrocarbon combustion is the primary process in the burning of fossil fuel. Next is the oxide of nitrogen. For the nitrogen dioxide, when the fuel are burned in the vehicle engine, high temperature are react. At this high temperature, nitrogen and oxygen from the air combine to produce nitrogen monoxide. When this nitrogen monoxide is released from the vehicle exhaust system, it's combined with oxygen and the air to the form nitrogen dioxide. This is the vehicle classification that might be familiar if you have seen on vehicle sticker. They have 6 categories, that is TLEV. That means transitional low emission vehicle. Secondly is LEV, low emission vehicle. ULEV, ultra low emission vehicle. SULV, super ultra low emission vehicle, and lastly is ZEV, zero emission vehicle. There is no such thing as a ZEV. So now we already know a little bit about the emission and the categories of the emission engine. Now we go into the emission control system. The emission control system is meant to employ to limit the discharge of noxious gases from the internal combustion engine and other components. This is roughly explanation for emission control system.
This section examines sources of emission from light vehicles. The term emission normally refers to the pollution produced by a light vehicle during normal use. Emission control systems are designed to limit the pollution caused by the harmful products of storing and burning fuel. Emissions from a petrol-driven motor vehicle usually come from four sources: the fuel tank, the carburetor, the crankcase, and the exhaust system. The fuel tank and carburetor allow fuel to evaporate and escape to the atmosphere. These are called evaporative emissions. The crankcase and exhaust system emit pollutants directly from the engine into the atmosphere. They are caused when hydrocarbons, lead compounds, and oxygen and nitrogen from the air are burned in the combustion chamber. In a compression ignition engine, emissions originate from the engine and escape to the atmosphere from the exhaust and the crankcase breather.
There are three main sources of this gas. That is the engine exhaust, the crankcase, and the fuel tank. Also the carburetor or throttle body. For the first one is the exhaust pipe. Exhaust pipe is a pipe that carries the gas or steam out of an engine. Exhaust pipe will discharge burnt and unburned hydrocarbon, carbon monoxide, oxide of nitrogen, and sulfur, and also trace of various acid, alcohol, and phenol. Secondly is crankcase. Crankcase is the housing for the crankshaft in the reciprocating internal combustion engine. In most modern engine, the crankcase is integrated into the engine block. Four-stroke engine typically have an oil sump at the bottom of the crankcase, and the majority of the engine oil is held within the crankcase. Crankcase is a secondary source of unburned hydrocarbon and to a lesser extent carbon monoxide. Thirdly is a fuel tank. In the fuel tank and the throttle body. The throttle body is an important part of air intake system that control the air flowing into your engine. It is located between your air intake and engine manifold, where fresh air is pulled into an engine for the combustion process. Hydrocarbon that are continually evaporating from gasoline constitute a minor but not insignificant contributing factor in pollution. So, we get into emission control system. Firstly is a PCV. PCV is a positive crankshaft ventilation. It is designed to remove unwanted gas from crankcase and to protect engine from corrosive and clogging slough. I will share the explanation video of PCV for the next slide. For the next is a EGR system. EGR system is an exhaust gas recirculation. It designed to recirculate exhaust gases into the cylinder to reduce combustion temperature. The system reduces the nitrogen dioxide. So, this is the video for EGR system.
Exhaust gas recirculation, EGR for short, is an important pollutant reduction method in petrol and diesel engines. Here we can see its basic structure. Exhaust gas is taken directly after the cylinders. Then, the EGR valve regulates the subsequent mixing of the exhaust gas with the intake air. This means that less oxygen reaches the cylinder. Less oxygen means a lower combustion temperature. This way, nitrogen oxide quantities can be reduced by up to 70%. As the higher the temperature, the more harmful nitrogen oxides are produced. In petrol engines, this can also reduce carbon dioxide emissions and fuel consumption. A key component of exhaust gas recirculation is the EGR valve. It meters the quantity of exhaust gas that is returned. EGR valves come in various designs and models, pneumatic or electrical, for petrol or diesel applications, or with connections for cooling. Regulating throttles are used in the intake air system in diesel vehicles. They generate the pressure difference required between the exhaust gas side and intake side to achieve the necessary high exhaust gas recirculation rates. Air mass sensors are required in diesel engines to regulate the exhaust gas recirculation, for example. With their help, the mass of the recirculated exhaust gas is calculated indirectly using the reduction of intake air. Since simple exhaust gas recirculation has no longer been sufficient to fulfill emission standards for some time, EGR coolers are used. Cooled exhaust gas reduces the peak combustion temperature even further. This again significantly reduces the amount of nitrogen oxides. Just like all components in the EGR system, EGR coolers are exposed to the extreme conditions of the aggressive exhaust gas condensate. They must therefore be manufactured from highly corrosion and temperature-resistant materials. Many of today's EGR coolers feature an electrical or pneumatic bypass flap. They allow the exhaust gases to be directed past the EGR cooler in the warm-up phase to quickly bring the engine and catalytic converter to operating temperature. This also reduces noise generation, the so-called diesel knock, and the raw emission of hydrocarbons in the warm-up phase. Bypassing is also possible if high exhaust gas temperatures are required, for example in the recovery of the diesel particulate filter. The previous high-pressure exhaust gas recirculation system is no longer sufficient for meeting the limit values as of Euro 6 and Tier 2. An additional low-pressure EGR system is required. With this system, the exhaust gas is taken after the particulate filter on the low-pressure side and added again before the turbocharger compressor. An exhaust gas flap provides the exhaust gas back pressure required for this. Pierburg is a significant contributor to the current state of the art. The first EGR systems were used in some petrol-driven vehicles as early as the 70s. In the 90s, this technology also began to be used in diesel vehicles.
Thirdly is the TAC system. TAC system is a thermostatic air cleaner. The TAC is used to provide warm air to the air cleaner during cool startup. This helps to improve cool engine performance and reduce automotive emission by providing better fuel vaporization. The TAC system is primarily used on carburetor or throttle body injected. This system reduces hydrocarbon, carbon dioxide, and nitrogen oxygen emission. The emission was reduced when the engine is cool. There has video that explain how TAC system work. Next is EFI system. EFI system is a part of modern computer control system. Electronic fuel injection EFI is a solution. The solution that guarantees a low emission as well as fuel consumption optimization for small motor that otherwise can be very polluting. This fact underlines the importance of trying to find a solution to reduce the impact. This fact underlines the importance of trying to find a solution to reduce the impact on the environment of such a type of motor. The electronic fuel injection system consists of electronic component and sensor. It has to keep clean and well calibrated to boost the engine strength and efficiency and to cut down gas consumption. This system reduces hydrocarbon, carbon dioxide and nitrogen oxide emission. After that, the emission control system is the three-way catalytic. A three-way catalytic oxide exhaust gas pollution has both hydrocarbon and carbon monoxide. It reduces nitrogen oxide into a harmless component such as water, nitrogen, and carbon dioxide. There has a video that explains how the three-way catalytes work.
In every vehicle, dangerous raw emissions such as carbon monoxide, nitrogen oxides, sulfur dioxide and hydrocarbons are produced during combustion in the cylinders. Different exhaust gas after-treatment methods convert these raw emissions into less harmful exhaust gases. Ideally, only nitrogen, carbon dioxide and water remain. The classic exhaust gas after-treatment method is the controlled three-way catalytic converter. It's called three-way as here three chemical reactions of reduction and oxidation occur simultaneously. And it's called controlled as the injected fuel quantity is adjusted so as to minimize the raw emissions at every operating point. The lambda is determined via the lambda sensor before the catalytic converter, also known as a control sensor. Taking this as an input variable, the engine management system controls the addition of fuel to ensure efficient and low-emission combustion. As an important component for emission control, the catalytic converter is monitored by the onboard diagnostics. If, for example, misfiring causes unburned fuel to enter the exhaust gas, this can damage the catalytic converter. Likewise, the catalytic converter's ability to convert pollutants decreases over time. We call this catalytic converter aging. Therefore, a second lambda sensor after the catalytic converter, also known as a monitor probe, monitors the condition of the catalytic converter. Lambda sensors measure the oxygen content in the exhaust gas. In this example, the monitor probe signal shown in red is noticeably lower than the control sensor signal shown in blue. This shows that the pollutants are being converted, as oxygen in the exhaust gas is reduced on the way through the catalytic converter. This catalytic converter is okay. In this example, the control sensor and monitor probe signals are almost identical. This indicates that almost no exhaust gas purification is taking place in the catalytic converter. This catalytic converter is defective. As a specialist in emission control, Motor Service of course offers a comprehensive lambda sensor range as well, all from a single source. They're available in different models, such as jump probes or wide-range lambda probes, heated or unheated, and with various connections for the different vehicle types.
Lastly is the fuel evap system. Fuel evap system is used to prevent gasoline vapor from escaping into the atmosphere from the fuel tank and the fuel system. The fuel tank of the vehicle hold the fuel, which make the car run. The gas tank can be made of plastic high-density polystyrene, which can be made into a complex shape. And a complex shape saves space and can improve crash safely. The gas tank can also be made out of a steel of aluminium, which is well from stamped sheet. The evaporation of the fuel is stored the fuel vapor in the charcoal canister until PCM command. This system is reduced from gasoline emission and make the fuel safe. So, for the conclusion, we can look how to manage this emission with three methods. That is engine design, controlling the air, and converting to the less harmful gas. Lastly, for the method that we can do is use the electric car. electric car and a effective way to reduce the emission control and can reduce the pollution as well. This is the video of the explanation of the difference between the gasoline car and the electric car.
Here's a question. How much cleaner are battery electric cars compared to gasoline-powered cars? To find out, the Union of Concerned Scientists studied the total global warming emissions of each vehicle throughout every stage of its life, from manufacturing to driving to disposal. And there's a big difference. Both cars start out on the assembly line with similar parts made of raw materials like steel and aluminum. For a gasoline car, this manufacturing and assembling stage generates about 7 tons of emissions. Battery electric cars, meanwhile, are powered by, you guessed it, a large battery. This requires more energy and materials to produce for an 84-mile range battery electric car, bringing its emissions tally up to roughly 8 tons. But what happens when they hit the road? Gas-powered cars produce pollution with every gallon of gas they burn, with even more emissions coming from extracting, refining, and transporting the fuel to gas stations. Electric cars, on the other hand, run on electricity, which can be much cleaner than gasoline, depending on how the electricity is made. 2/3 of Americans live in regions where charging an electric car produces fewer global warming emissions than driving even a 50-mile-per-gallon gasoline car. By the end of their lives, the average gas car will rack up 57 tons of global warming emissions, compared to 28 tons for a battery electric car. Disposing and recycling each car adds less than 1 ton of emissions. And remember that electric car battery? It can be recycled or reused. In the final tally, an 84-mile range battery electric car cuts global warming emissions by more than 50% compared with a similar-sized gas-powered car, making up for the battery's manufacturing emissions within 1 year of driving. And as the country adds more and more renewable sources of electricity, driving electric will get even better. So there you have it, straight from the engineers at the Union of Concerned Scientists. Electric cars, clean and getting cleaner.
That's all from me. Thank you.